Is it on? Is it on?
Welcome 4th and 5th graders. I'm Hannah and this is my companion Lana. Today we'll be showing you some experiments.
Don't worry, we'll explain everything in more detail as we go.
The first experiment is zinc and copper sulfate.
So you'll take the zinc and you'll take the copper sulfate, which is blue, and you'll have to have a test tube and something to cover the test tube. So you'll take some of the copper sulfate, put it in the test tube, and then you'll take the zinc and put it in the test tube and put something on top of it so it doesn't fall out or get on your fingers. And when you shake it, it turns black and it starts disintegrating. So basically what we did is that the copper sulfate that was in the test tube was then taken and the zinc was put into the test tube with the copper sulfate. So then when you do put the zinc with the copper sulfate and you cover it up, the zinc should eventually turn black and it start disintegrating. And the reason why is because the zinc is being oxidized, which means it will gain charge. So it starts with a 0 charge and ends up with a +2, while the copper sulfate is being reduced. So it starts with +2 and ends with 0, which leads to the zinc turning black. Now, 4th and 5th graders, we're going to show you the experiment of ammonia and copper sulfate. So we have the ammonia, which is clear, and the copper sulfate, which is a light blue liquid. And you'll start with putting the ammonia into the test tube. And after, you take copper sulfate, the light blue liquid, and put it into the test tube. It turns into a darker blue than the copper sulfate, and it becomes more cloudy. So now we're going to see that ammonia is a compound, which that means it has anions, which are negative charges, and copper sulfate is an ionic compound that has both cations and anions, which are positive and negative charges. So you'll get a beaker or a test tube, and you put both liquids into the test tube or beaker, and it'll make the light blue liquid from the copper sulfate turn more into a darker liquid, which it will also mean that the ammonia has made the color darker because of how the negative charges, and it also will precipitate, which also means cloudy. Wow, 4th and 5th graders, that was a pretty cool experiment. Now let's see about ammonia and phenolphthalein. So now we're going to be dealing with ammonia and phenolphthalein. And these two liquids are clear. Now we're going to take the ammonia and put it into the test tube. And then after that, we're going to put the phenolphthalein into the test tube, which creates a darker color, like a purplish. P-U-R-P-L-E, purple. Ammonia, which is a base, and phenolphthalein, which is an indicator, will make a purple substance. But whenever you take a base and an indicator, it'll always make a purple liquid. Last but not least is hydrochloric acid and magnesium. So we're going to be taking HCl and a magnesium strip and a test tube with a pH strip. So we're going to take the HCl and put it into the test tube, which is also a clear liquid. And we're going to take the magnesium strip and put it into the test tube, which makes a chemical reaction of it bubbling and fizzing. So after that, we're going to let it fizz for a while, and we're going to take the pH strip and see what the pH is. and it turns out to be red. pH means power of hydrogen. And so to be able to find the pH, we use a number line that will help us figure out if it's an acid or a base. So we're going to use the number 7 and put it in the middle. And then one line will be higher than 7. The other side will be lower than 7. So anything lower than 7 will be an acid. Anything higher than 7 will be a base. And the exact number of 7 is neutral. So it's not an acid or a base. So magnesium and HCl, which is hydrochloric acid, switches to magnesium with chloric acid and hydrogen, which is a single replacement and means that magnesium took part of the hydrochloric acid and hydrogen is alone. So that leads to our pH being 2 because of the color it was red, which means it's an acid.